Hello everyone, and welcome back to my channel again. So in this video, I'm going to explain something about transient response of series RL circuit for DC excitation, and also RC if possible, or else I'll upload in next video. Okay. So for this derivation, first let us consider series RL circuit. So it is considered that the transition, or else the transition that will take place, transition takes place at instant t equals to 0. Transition takes place at instant t equals to 0. So now let, let us consider a circuit. You can see already drawn the circuit. Consider a circuit which is having a resistor R and L which are connected in series across voltage source. So there will be a transition happen, so that I'll be having the switch, and when switch at t equals to 0 it is closed. I'm defining switch as S. So now let initial current flowing through the inductor can be denoted as I naught. So I naught means initial current that is flowing through the circuit. So at t equals to 0 switch is closed, so that at t equals to 0 means before closing switch it is open. Now at t equals to 0 the switch K or else S, instead of S or else K or S is open when t equals to 0 minus, and again it is closed when t equals to 0 plus. 0 minus andre switch close ಆಗಿಂತ ಮುಂಚೆ, t equals to 0 ಅಂದ್ರೆ ಸ್ವಿಚ್ ಕ್ಲೋಸ್ ಆಗಿರುತ್ತೆ, 0 ಮೈನಸ್ ಅಂದ್ರೆ ಸ್ವಿಚ್ ಓಪನ್ ಆಗಿರುತ್ತೆ, ಆರೋ ಮಾರ್ಕ್ ಡೌನ್ವರ್ಡ್ ಇದ್ರೆ. ಮತ್ತೆ 0 ಪ್ಲಸ್ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಸ್ವಿಚ್ ಕ್ಲೋಸ್ ಆಗುತ್ತೆ. ಇವಾಗ ಸ್ವಿಚ್ ಓಪನ್ ಇದೆ. ಸೊ ಓಪನ್ ಇದ್ದಾಗ ಏನ್ ಮಾಡ್ತೀರಾ, ಆಸ್ ವೋಲ್ಟೇಜ್ ಇಸ್ ನಾಟ್ ಅಪ್ಲೈಡ್ ಟು ದ ಸೀರೀಸ್ ಆರ್ ಎಲ್ ಸರ್ಕ್ಯೂಟ್. ಇವಾಗ ಸರ್ಕ್ಯೂಟ್ ಓಪನ್ ಆಗಿರೋದಕ್ಕೆ ದೇರ್ ಇಸ್ ನೋ ಪಾಸಿಬಿಲಿಟಿ ಆಫ್ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಥ್ರೂ ದಿಸ್ ಸರ್ಕ್ಯೂಟ್. There is no possibility of flowing the current, so that as voltage is not applied to the series RL circuit, current in the circuit will be 0. Means t equals to 0 minus idaga switch enagutte, switch is open, and t equals to 0 idaga switch close, and again t equals to 0 it is greater than or equals to 0 plus idaga enagutte matte switch close. So ivaga t equals to 0 minus idaga switch enagutte, open agutte. Open idaga there is no possibility of flowing current because of the open circuit, so that current through the inductor will be 0. At t equals to 0 minus, I of 0 minus is 0 before closing switch, and that will be same as I of 0 plus, as we already explained in our previous video. So in case of inductor, current flowing through the inductor cannot change instantaneously, so that I of 0 minus is the same as I of 0 plus, that is nothing but 0. And I already defined initial current, that's nothing but when t equals to 0 minus I naught is flowing, so that I am writing this as I naught. I am giving this as equation number 1. First ಏನು ಮಾಡ್ತೀರಾ, ಇನಿಷಿಯಲ್ ಕರೆಂಟ್ ಫೈಂಡ್ ಮಾಡ್ತೀರಾ. ಇನಿಷಿಯಲ್ ಕರೆಂಟ್ ಫೈಂಡ್ ಮಾಡಬೇಕಂದ್ರೆ ಬಿಫೋರ್ ಕ್ಲೋಸಿಂಗ್ ಸ್ವಿಚ್ t equals to 0 minus ಇದ್ದಾಗ ಸ್ವಿಚ್ ಏನಾಗುತ್ತೆ, ಓಪನ್ ಆಗುತ್ತೆ. ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ಇರೋದಕ್ಕೆ ಕರೆಂಟು 0 ಆಗುತ್ತೆ. ಸೊ ಕರೆಂಟ್ 0 ಆಗಿರೋದಕ್ಕೆ ಕರೆಂಟ್ ಇಂಡಕ್ಟರ್ ಇಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಿರೋ ಕರೆಂಟ್ 0 ಆಗುತ್ತೆ ಅವಾಗ. ಸೊ ಆಸ್ ಐ ಆಲ್ರೆಡಿ ಟೋಲ್ಡ್, ಇಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಿರೋ ಕರೆಂಟ್ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ ವೆದರ್ ದ ಸ್ವಿಚ್ ಇಸ್ ಕ್ಲೋಸ್ಡ್ ಆರ್ ಓಪನ್, ಸೊ that cannot change instantaneously, so that the current flows to the inductor before closing switch, that will be same as after closing the switch. You are defining that as I naught. Yavaga before closing, when t equals to 0 minus. Now when t equals to 0 plus, or else when t is greater than or equals to 0 plus, t equals to 0 idaga switch close irutte, t equals to 0 minus idaga switch open agutte. Again t equals to 0 plus idaga switch ಏನಾಗುತ್ತೆ, open. That is nothing but greater than or equals to 0 plus idaga. So now the circuit which looks like this, switch is closed. Now switch K is closed, K or S whatever defined. So once after closing the switch, now it is a closed circuit. So now we can find current, or else you can get the equation by applying KVL. So now you apply KVL. So apply KVL. Current is flowing in clockwise direction. You are marking the polarity minus plus, and through the resistor it is flowing from plus to minus. Again through the inductor it is flowing from plus to minus. Voltage across inductor na VL of T ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀರಾ, and voltage across resistor na VR of T ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀರಾ. T is nothing but time dependent voltage, time dependent current. So you are applying the KVL, so that V equals to, or else minus R into second polarity minus R into I of T minus L into di of T, that is nothing but voltage across. This is nothing but VL of T, that is nothing but L into dIL of T divided by dt, that is nothing but L into di by dt plus V equals to 0. So you are rewriting here again, you are sending this to the right side. So it becomes R into I of T plus L into di by dt equals to V. So next what you're doing, you're dividing L on both sides. Means you are dividing this with the help of, in LHS and RHS you are dividing, so that, so for this equation, dividing both sides. So if you're dividing means R divided by L into I of T. Then L by L is nothing but 1, that is nothing but di of T divided by dt, that is equals to V divided by L, dividing L on both sides. So you are giving this as equation number 2. So now equation 2 is in the form of differential equation first order, that is nothing but it is in the form of dy of t divided by dt plus p. This is from mathematics, you will get directly first order differential equation and its solution. It is in the form of dy of t by dt plus p into y of t equals to q, and solution of this is y of t equals to q divided by p plus k into e to the power minus pt. So ಈ solution ನ equation 2 ಜೊತೆಗೆ ಕಂಪೇರ್ ಮಾಡ್ತೀರಾ, that is nothing but di of t by dt ಜೊತೆ. So you're comparing that with that. So whenever comparing, so y of t is nothing but I of t, and p is nothing but R divided by L, and q is nothing but V divided by L, so that y of t equals to I of t, p equals to R divided by L, q equals to V divided by L. So once after writing in this form, equation 2 becomes, the solution of equation 2 becomes now I of t. Y of t is actually I of t equals q divided by p. Q is nothing but V divided by L, divided by p is nothing but L divided by R. L and L will get cancelled. Plus k into e to the power minus p into t. P means R by L. K into e to the power minus R divided by L into t. Solution of differential equation. So that you can write I of t equals V divided by R plus k into e to the power minus R by L into t. This is equation number 4. So now you need to find the value of this constant k. So to find the value of constant k, you know that before closing switch, that is when t equals to 0. So now the switch condition will be like this at t equals to 0. When t equals to 0 minus, switch is closed. Again when t equals to 0, t is greater than or equals to 0 plus, switch is again, sorry, t equals to 0 minus, switch is open, not closed, and t equals to 0 plus, switch is again closed. So that t equals to 0 minus means switch kept open, so that I of 0 minus equals to 0. T equals to 0 plus means switch is closed, as know that current flows to the inductor cannot change, so that I of 0 minus equals to I of 0 plus, the value of that will be 0. For initial value condition, now put t equals to 0 minus equation 4 ಗೆ, to equation 4 substitute the value of t. T ಇರೋ ಜಾಗದಲ್ಲಿ ಏನು ಮಾಡ್ತೀರಾ, minus 0 ಬರೀತೀರಾ, so that I of 0 minus, this becomes I of 0 minus equals to V divided by R as it is, then k into e to the power minus R by L, t ಇರೋ ಜಾಗದಲ್ಲಿ 0. e to the power 0 is nothing but 1, so that it will be k. I of 0 minus is nothing but 0, so I substitute the values of that. So I of 0 minus is 0, so you can see here I of 0 equals to v by r into k into e to the power 0 is 1, so that plus k, 0 equals to v by r into k, so that you can get the value of k, that is k equals to minus v by r, the value of k. Okay, to find the value of k, you're substituting t equals to 0 minus. So now once after knowing the value of k, substitute this value in equation 4. What equation 4 says now? I of t. Substitute the value of k. K is minus v by r. So once after substituting here, I of t equals v by r. K is minus v by r, minus v by r into e to the power minus r by L into t. Take v by r as a common, 1 minus e to the power minus r by L into t. The same solution you will be getting here. See, I of t equals to, so the equation 4 is nothing but I of t equals v by r plus k into e to the power minus r divided by L into t, where just now we got the value of k, that is nothing but minus v by r. Substitute to this equation v by r minus v by r into e to the power minus r by L into t. So you are taking v by r as a common, you can get I of t equals to v by r into 1 minus e to the power minus r by L into t. So this represents current response. This is a current response of series RL circuit. Okay, similarly you need to write the voltages. So I of t, when t equals to 0 minus, I of t equals to v by r, that will be nothing but inductor that will be act as short circuit. And the next concept is continuation of that will be time constant. So time constant is nothing but a time required for the current that will be rises to 0.632 times of its final value is known as time constant. And it is also defined as the ratio of inductor to resistor, tau. This is time response, or sorry, time constant in terms of seconds. So for this time constant, so we know that I of t is given by, we know that I of t is given by v by r into 1 minus e to the power minus r divided by L into t. Here you substitute t equals to tau. So that v by r into 1 minus e to the power minus r by L into tau. Okay. So that I of t equals, and also you know that what is tau? Tau is nothing but L by r. Tau is nothing but L by r. That is also nothing but t. So that v by r equals to 1 minus e to the power minus r by L into, where there is tau, there you have to substitute L by r. L and L will get cancelled. R and R will get cancelled. V by r into 1 minus e to the power minus 1. So e to the power minus 1, you just substitute in your calculator, you can get I of t equals 0.632 times of v by r. This is tau, time constant, 0.632. So now we can see the definition. What it says, time required for the current rise to 0.632 times. See, 0.632 times of final value. Final value is v by r. So this is a time constant. Similarly, you need to substitute when t equals to 2 tau, 2 times of time constant, 4 times, 6 times. It keeps on increasing. The time constant will be increasing and it reaches a maximum value. So that you can see when t equals to 2 tau, that is nothing but 2 L, tau is nothing but L by r, 2 into L by r, substitute here e to the power minus 2, e to the power minus 4, e to the power minus 6, substitute in your calculator, you can get 0.8646 times of v by r. And also at t equals to 4 tau, we can get 0.9816 times of v by r. And t equals to 6 tau, we can get 0.9975 times of v by r. That is nothing but initial rate of rise in a current is high, that is 0.632. So you can get this graph for that. I of t with respect. See here, this is time constant. When tau equals L by r, the current response I of t becomes 0.632 times of V by R. If it is a 2 tau, again it will be rising. Till where it rises, till that will be equals to final value. That is nothing but V by R. Here it becomes constant once it reaches. If the time increases, current is also increases and it reaches a maximum value when it is when the final value of current which will be reached. Okay, so this is about time constant. Similarly, if you want to find voltage across L, so voltage across L, to find the value of voltage across L, you are defining VL of t is nothing but you know that V equals to L into di by dt. Voltage across L, VL of t equals L into di of t by dt. So I of t, we know what is I of t. I of t is nothing but V divided by R into 1 minus e to the power minus R by L into t. Substitute this value here and do differentiation. So L into d by dt of I of t is nothing but V by R into 1 minus e to the power minus R by L into t. Now we can do the differentiation of this is that is nothing but L into multiplying, opening the bracket, d by dt of, you can see you just open d by dt of V by R minus d by dt of V by R into, this is multiplying here, V by R into e to the power minus, if you want I'll write it here, L into d by dt of V by R, opening the bracket, V by R, then V by R into e to the power minus d by dt of V by R into e to the power minus R by L into t. Here you can see. So differentiation of V by R with respect to t is 0 because there is no terms in terms of t, so that it is 0. Similarly here e to the power minus R by Lt, that is nothing but minus V by R. V by R will be taking outside, minus V by R it is now d by dt of e to the power minus R by L into t. Differentiation of this is minus R by L into e to the power minus R by L into t. Okay, R and R will get cancelled, minus into minus become plus, you can get voltage across the inductor is V into e to the power minus R by L into t. So now you can substitute the time constant if you want, then we'll get the values. Similarly, voltage across resistor, you know that simply voltage across inductor is V into e to the power minus R by L into t, VL of t. Similarly, if you want to find voltage across resistor, you know that VR of t, that is voltage across resistor, is given by R into I of t. Substitute the value of I of t, that is V by R into 1 minus e to the power minus R by L into t. R and R will get cancelled. What will get? V into 1 minus e to the power minus R by L into t. Okay, so this is a graph. So this is time constant tau, and this is a final value. And here you can see when the tau which will be increases. Similarly, this is voltage across inductor. Voltage across inductor. This is a graph. Similarly, the next concept is transient response of series RC circuit for DC excitation. The procedure and methodology which is same. And I hope you are understanding the previous concept. If you're having any doubts, take a screenshot and try to practice. And it is very easy and very important. They asked many times in the examination, so that it is important. Practice it well. Okay, so thank you so much for watching this video. If you have any doubts regarding this, feel free to write in a comment box. So at the same time, if you like this video, do share maximum and subscribe. Thank you so much. Have a nice day.